There we go. Okay, first of all, any questions about the midterm for Friday? Want me to review anything? Or is everybody on a decent page? Go ahead.
How much actual coding is going to be?
Oh, just a ridiculous amount.
Right.
I want to say maybe there might not be any coding.
Okay.
Was there any coding?
I mean, on the study guide, I think you said light coding.
Yeah, but I actually wrote the exam. I gave it to somebody already.
Oh, okay.
So yeah, no coding made it on there, right?
Yeah, I don't think so. Okay.
Lucked out. It's going to be some coding on the other ones. There's some coding on the other ones. All right, any other questions? I don't remember which test was which. Was this the one that had 14 questions on it? Something like that. Huh? No, he took the test already. 14, yeah. He took it this morning because he's going to be out of pocket the next couple of days. All right, any other questions? Okay, so let's keep talking about our JSON stuff. I think what we started seeing last time is we almost run into this infinite problem where we could say, oh, well, this is an object. And an object contains what? It's a collection of variables. Well, what's a variable? A variable is a variable name followed by a value. What's a value? A value can be a simple value. It can be a dumb value. It can be an object. It can be an array. So you can keep diving down farther and farther and farther, right? Now, that has built into it this concept of recursion, which he brought it up a couple classes ago. But I kind of wanted us to hit this wall with recursion. So what we want to do is we want to go back and we'll use a lot of the code we already wrote, but we want to rethink this. And we're going to see that when we write this more modularly, it actually becomes easier to write. Okay? So what I'm going to do for our starting point is I'm going to create a new object just to keep things separated. So we'll create a new class. Let's call this JParser. Reasonable enough instead of JSON parser. So this guy's going to be JParser. And our constructor for JParser will take a JSON string. Now, if you remember correctly, inside of JSON parser, we had this constructor, and then what did we do? Inside the constructor, we went to town. That's the body of our constructor. We're not even done yet. That's the body of our constructor right there. So we kind of went to town on that. So that was, so it ended on line 170, began on line 11, so 159 lines of code for that. And even with that, it wasn't good enough. Because as soon as we started creating JSON vars, we have a situation where, oh, this guy might be even more complex, meaning we might need to parse it even further. So it might have more complex values. It might have this variable might have a value that's a JSON object or a JSON array. So our endpoints are simple values and dumb values, right? That's when we know we're done. But if we have a JSON object or a JSON array, we need to deal with those. So we're going to write this inside of JParser. So I'm just going to create a little comment called Parse the Json. We know that we're always going to start JSON with an opening curly brace. Now before, we did this mechanical thing where we just ripped off the opening and closing curly braces. We're not actually going to do that this time. What we're going to do is we're going to have a couple of private methods in here. So we'll call Parse Json. And Parse Json is going to walk through our JSON string, finding the opening curly brace. Then we know we're at the beginning. Okay? And you're going to kind of see how modular this is here in a second. I'm going to create another variable up here. Int pause. And we'll set pause equal to 0 initially. Pause is going to be where we are within a string at any point in time. That make sense? Now, we may end up using a global pause, or we might use a more local pause. But I'm going to start with a global pause here, and you'll kind of see the difference as we get into this. So the very first thing we do is we parse JSON. That makes sense. If I have a JSON document in front of it, I want to parse this. Very first thing I do is look for the opening curly brace. Right? How do you spell opening? One end or two ends? Two ends. One? Is that right?
Yeah, that's right. Yeah.
Three ends?
4?
One's right?
Yeah.
All right, fine. Fine.
Are there
All right.
any words that have 3 consecutive?
Well, there has to be.
Is there?
Well, I don't think really, but I think people like do that, right? Doesn't it like add like excitement to words and stuff by putting like woot can be W like with 30 O's and then a T, and that means like, wow, I'm really excited about what just happened, right?
Yeah.
Okay, so we're going to look for that opening curly brace, and we're going to adjust pause as we do it. So while JSON dot char@pause is not equal to an opening curly brace, pause plus plus. Make sense? So as soon as we hit an opening curly brace, we'll be sitting right here knowing that pause is currently that opening curly brace. We'll move past it. So now we're sitting right on the other side of that opening curly brace. If we are just inside a JSON, just inside that opening curly brace, what's the next thing we're looking for? Variable name. So we're going to create another function. And we might give values to these return types, but for right now, we'll keep them void. I'm going to call this guy parse variable initially, because that's what we're doing. We're processing an individual variable. Okay, so what's the very first thing we do? Look for the var name. So while JSON.char@pause is not equal to a double quote. What are we going to do? Increment pause. We're going to keep walking until we hit a double quote. As soon as we hit a double quote, we'll exit this while loop, and now we're sitting at that double quote. And we know that our variable name is everything from there to the next double quote. Make sense? All right, so let's go ahead and right at the top of parse variable, let's create our, so let's see, string var name is equal to the empty string. So now we're sitting right here, and we're going to say var name is equal to var name concatenated with JSON.char@pause. And then we'll move one past that. Now, we're going to do the exact same thing. We're going to look for the second, the closing curly brace. So as long as we didn't hit another curly brace, we're going to keep tacking on the characters, incrementing pause each time. As soon as we hit that final character, we'll add the closing double quote and move one past it. So look for var name means find opening double quote, forends, find opening double quote, find closing double quote, what's the next thing we do? Now we got to burn past our colon, right? Always have colons separating our variable values. So now, while, here, find the colon, while json.char@pause is not equal to a colon, pause plus plus. So we'll move past that colon. Well, we'll move to the colon. Once we exit here, we know we're sitting at the colon, so we'll say pause plus plus. That moves right past it. Now the next thing we're looking for is what? The value. That make sense? So to make this a little more modular, what we're going to do in parse variable is we're going to write another function. Well, a complementary function. So we're going to have a private void parse variable name. And parse variable name is going to have all this crap that we just wrote in here. So I'm going to cut it from there and I'll paste it into parse variable name. Okay, so when everything's done here, var name should have that variable name in it, right? So we're going to go ahead and have this guy return that string. So I made the return type string, and then I return the var name that we just built up. And we know we are currently sitting at one character after the closing colon. That's where this method leaves us, right after that closing colon. So parsing a variable means what? Well, we're going to have, we'll make it local first, string var name is equal to this dot parse variable name, and then string dot var value is equal to this dot parse variable value. What might change here is we're not dealing with a string. We might be dealing with a JSON var or something else. So before we even do this, let's go and write that function. So we're going to write a function called parse variable value. We'll start it off as void. Now, because pause is a global variable, we know at any time where we are in that string. We keep adjusting this global variable pause. Make sense? So, parse variable value, we know when this guy gets called, we will be sitting immediately following that colon. Why? Because that's when we're going to call it. This dot parse variable value. Right now it doesn't return anything, but we'll just remember to call it. So what does it mean to parse a variable? It means get the variable name, get the variable value. See how we're modularizing that? So this is the crap to get the variable name. I'll go ahead and minimize that. That's what this little thing over here is. So that does the variable name. See, I can expand it if I want. So that just keeps our code a little cleaner. Parse variable value. I know I'm sitting right after the closing curly brace. So for right now, let's do, I'm actually not going to create a string yet. So for right now, we're looking for what? We're looking to burn past white space until we hit either a double quote, something that's, well, a double quote, an opening curly brace, an opening square bracket, or something else non-space, right? Those represent our 4 different kinds of values. So while json.char@pause is not equal to, I'm going to create a little function here. Private boolean is var val starter. And this guy is going to take a char as a parameter. And we want this guy to return true if what? Well, we want it to return true if we're at the beginning of a variable value. That means we're looking at a double quote, we're looking at an opening curly brace, we're looking at opening square bracket, or we're looking at something else that's non-white space. Now remember, the point of this guy is to parse a variable value. That's what we're working at right here, right? Parse variable value. We have 4 different variable values to parse. The first one is the simple variable value, where we're looking for an opening and we're looking for a closing, right? So if I'm walking through here and I find the beginning character, and that beginning character is a double quote, what do I want to do? That's our simple value, correct? How do I capture that? Maybe call parse variable value simple, or parse variable simple value, something like that. So we want to still modularize this. So I'm going to write this anyways for right now, but we're going to see that this guy actually isn't that useful for us for the part we're doing right now, but we're going to write it anyway. So we're going to return C equal to an opening curly brace, or C equal to an opening square bracket, or C equal to a double quote, or C not equal to a space. If at least one of these are true, we're looking at a var val starter. That make sense? So we'll go ahead and we'll burn to the beginning of our variable val. So I'm going to say while this dot is var val starter json.char@pause while not. So while we are not looking at a var value starter, pause plus plus. Keep walking. So as long as I'm hitting white space or something that is not the beginning of my variable value, I just want to keep pause cooking, right? As soon as I'm past that, I am at the beginning of the value. So that means I'm either looking at a double quote, I'm looking at an opening curly brace, I'm looking at a opening square bracket, or I'm looking at a number, something like that. Number or Boolean, I think, were the 2 that were supported, right? So that are dumb values that we Okay? So what we're going to do is we're going to write functions for parsing a simple value, parsing a JSON object, parsing a JSON array, and parsing a dumb value. Those guys are going to give us our values. Now a simple value is going to produce for us a string, right? A dumb value probably should produce for us a string. What about a JSON object? If I'm parsing a JSON object, what is a JSON object? If you had to concisely describe a JSON object, and I want to put this into a slide. So JSON variable types. We have simple. We have what we've been calling dumb. Just the value, no double quotes around it. Then we have a JSON object. What is a JSON object?
It's a collection of variables that can be a name and a JSON object again, and the JSON objects can be simple or dumb or JSON object.
Yeah, so a JSON object is a collection of JSON variables in between opening and closing curly braces, right? It can be any kind of JSON variable. It could be simple variables, it could be dumb variables, it could be more objects, it could be an array. That makes sense? But it'll always be a JSON variable. Just so happens that we already have the ability to parse variables. Okay? So a JSON object is a collection of JSON variables separated by commas. That's what a JSON object is. How would we store that? We said we're probably going to store this guy as a string. We're probably going to store this guy as a string. What's a JSON object? So JSON variables come in 4 flavors. A JSON object can be a simple, or a JSON variable can be a simple variable. That's one flavor. It can be a dumb variable. That's another flavor. What is a JSON object? How would you store that? What are we representing with JSON objects? Why do they exist? Well, it's a collection of variables, right? And those variables can be any of these types. When we hear collection, what do we immediately start thinking from a programming perspective? Okay, storing crap, right? Collection in real life, we have a box. We're going to throw a collection of crap into that box, right? So we need to have some sort of container for holding our collection of JSON variables. That make sense? So I'm thinking what we do, so I'm going to create another class here. We're going to have something called a JVAR. JVAR. I'm going to make JVAR abstract. What does it mean for a class to be abstract? Those of you who are in 250 aren't going to have this yet. The rest of you should know. Class that can't be instantiated. We don't want to ever be able to create generic JVARs. We want to be able to create simple JVARs, or dumb JVARs, or JVAR objects, or object JVARs, or array JVARs. We want to be able to instantiate those types of JVARs, not a normal JVAR. That makes sense? But what do all JVARs have in common? every single one of them will have a what? Variable name. Every single one of them will have a variable name. Okay? Every single one of them will also have a value, but those values may be different types. That make sense? So I'm going to go ahead and I'm going to create a constructor for this guy. Public jvar Okay, so we're really going out of our way here to create very modular code. I think in the end you're going to see how clean this ends up being. Okay, especially when we compress a lot of our stuff like we've done over here in jparser. We kind of compressed a couple of our functions here. Okay, so to build a jvar, we have a constructor. That constructor takes in a string and sets this guy's var name to that string. Now we might say, okay, wait a minute. You made this guy abstract, which means you can't create an instance of this. If you can't create an instance of something, why the heck do you have a constructor? The inherited object is going to use the constructor. So let's deal with our simple version first. So I'm going to go and create another class. And we're going to call this guy a J simple var. Okay? And we're going to say a J simple var extends jvar. All right. Now, we're going to have a public J simple var that takes a string, var name as a parameter, and also this guy's going to take in a string var value as a parameter. Because simple vars, we're going to store the values as a string. So for this guy, we're going to have a variable type string called var value that we're going to store globally within there. Very first thing we're going to do is we're going to call our parents constructor, super passive var name. So we're going to rely on jvar's constructor to take in our variable name and set the var name variable that we inherited to whatever we passed in. Okay, so that's how we call our parents constructor. Super. Then we'll set this dot var value equal to var value. Okay, so for right now, we're not going to give ourselves any other methods in here until we start needing those. What we just did is we gave ourselves the ability to store a J simple var. Can't do anything with it yet, but we can store it. All right, so let's go back into our jparser. If I'm in parse variable, first thing I'm going to get is the var name. Then I'm going to get the variable value. Now the variable value is right here. This is where we burn. We're at the beginning of the actual value. Then we need to collect it. Now that value can fall into a couple of different categories. So if Json dot char@pos is equal to a single quote, then I want to parse a simple variable. Does that make sense? So I'm going to give ourselves a function for that, a method for that. So I'm going to create another method, private. For right now, we'll keep it void. Parse simple variable value. Now remember, pause is already at the beginning of that variable. And we know we're collecting a string. So I'll say string var value is equal to the empty string. Actually, we can say string var value is equal to the empty string concatenated with json.char@pause. That'll get that opening double quote. Then we could say pause plus plus. That moves us past that. While json.char@pause is not equal to a double quote. As long as we haven't hit the end of that variable value, let's just build it. Var value is equal to var value concatenated with json.char@pause. As soon as we're past that while loop, we know we're looking at our closing curly brace. So we'll go ahead and grab, our closing double quote. So we'll go ahead and grab that. And now var value is complete. We just completely captured a simple variable value. Make sense? Well, we now have the ability to build a JVar because we have that value. So what I'm going to do here in JParser is we're going to have a parse simple variable value return a string. That'll be the actual value. So we're going to return a string here. Now, by returning, this will be var value. We need to think about how things get passed through here. To get to parse simple variable value, we first had to start off with parse variable. First thing we did is we grabbed the variable name, always a string. Then we called parse variable value. Parse variable value came in here. We got to our beginning of our variable. It's right here, parse variable value. We got to the beginning of our value, read it in. Notice it's a simple value, so we're going to call this dot parse simple variable value. And this guy's going to give us some answer back. When we are parsing a variable value, this is the generic version. If I give you some JSON, I say, get me the value associated with this. What should that method return? Okay, probably some kind of object, a value object, or it could be our JVar object, some kind of object. But we can't just do it as a generic string because not all of our values are going to be strings. This guy really needs to return an object. Let's just say that the var variable value is going to return something of type JValue. Okay? Right now we have something called a JVar. A JVar, we've decided, always has a variable name. Could we say that a JVar always has a variable name and also always has a JValue? Is that a fair statement? Every single variable in JSON has a variable name, which is always a string, and has a value, which is always something that we're going to call a JValue or JVal. So we're actually going to make this class non-abstract. We want to be able to create instances of that. We're going to make this guy private. The constructor for JVar is going to take in a variable name, and it's also going to take in a JVal or a JValue, whatever we want to call it. It's called a JVal. So we need to create another class. So we'll create something called a JVal. We'll make this guy abstract because not all JVals are created equal. Right? But let me ask you this. We have 4 different types of JVals. 2 of them are strings. The values are stored as strings. But we probably want to be able to differentiate between a simple value and a dumb value, right? That's going to be beneficial for us. So we're going to make this guy abstract and then create 4 subclasses. One for J simple val, one for J dumb val, one for J object val, and one for J array val. We have 4 separate objects, all inheriting from this guy. Now, having said that, what do all JVals have in common? Values don't have a name. All J variables have names. Do JVals actually have anything in common with each other? Well, they all have a value of some type. Oh, well, think of at the top level. If I give you some blocks, and those blocks come in 4 flavors. We have a red block, a yellow block, a green block, and a blue block. Okay, and those blocks represent our 4 different kinds of JSON values. Is there anything in common between the red block and the blue block? They're both blocks, right? Isn't that just like saying everything's a JVal? You know, a block is a block. It's just kind of a knowledge, an abstract idea that these are all vals. There's an abstract idea that we're looking at a collection of blocks in front of us. The blue block and the red block, they're both blocks, but there's no commonality between them other than our assumption that we know what blocks are. There's no common data being shared. Okay, so we're going to create our JVal as an abstract class. Do that initially, at least. And we're actually not going to put anything in here. Not even a constructor. Because we are never going to use this. Other than for creating collections of JVals. To support our JSON objects. And also it's going to support our JSON arrays. So I want to have this kind of a global name called a JVal that I can call anything that happens to be a JVal. And we're going to have 4 flavors of JVals. This is no different than this example we just talked about in real life, taking this away from programming and say, I'm going to create this concept, this abstract class called block. And a block is nothing except an idea. And now we're going to create classes for red blocks and blue blocks and red blocks, and what did I say, yellow blocks, whatever. So, you know, those 4 different kinds of blocks. And we're going to have each one of those guys inherit from the abstract type block. Every one of those guys is a block. But each block may have different characteristics. But we can still globally refer to them as a collection of blocks. So if I'm going to build a box, a collection, this gets back to how we're going to represent our JSON objects. If I'm going to build a box capable of holding blocks, I expect to be able to throw any kind of block into that box. That make sense? That's what we're building here. We're building a generic JVal object so that we can create a collection of JVals, knowing that none of them are this generic block. There's no such thing as a block. You know, if we're looking at these guys, we're going to say, okay, well, that's a red block, that's a blue block, that's a yellow block. That's just a block. That doesn't make sense, right? We're going to give some sort of descriptor to a block. So there's no such thing as just a simple, as a nothing block. Now, there's kind of 2 ways we could pull this off programmatically. In Java. We can create an abstract class, which is the way I like to do it, because this is actually the way that makes the most sense. You could technically also pull this off with something called an interface. I don't think interfaces I think interfaces make less sense than abstract. What an interface says, instead of extending an object, we are implementing an interface. And typically when we implement an interface, we're saying everything that implements this guy must provide this functionality. Okay, so in real life, when we're thinking about how interfaces might work, when you go to a Home Depot or something and they have those little scanner things, you know, there's probably 50 different companies that make the scanners that, you know, you scan barcodes. Every one of them has to implement the scan barcode feature. Okay, so if this was a Java interface, we would have something called scannable or something like that as the name of the interface. In this case, we really don't have anything to say. We kind of just want to create this descriptor class at the top and say all of these guys are in fact JVals. And that's really the purpose of inheritance. So we could pull this off two different ways. If we're going to make an argument for which one kind of makes the most sense, I would say the abstract class makes the most sense for this. All right, so we're going to create our JVal abstract class. And then I'm going to go ahead. We're going to create another class. And this guy's going to be a JSimple val.
So that's different from the JSimple var.
Yeah, don't even think about JSimple var for a second. Kind of unnecessary for a moment. It is different than it. It's, I guess, the short answer to your question. We're going to say JSimple vals all extend JVal. Okay, so JSimple val extends JVal. So every single one of these guys we create, we can say it's true that that guy is a JVal. Red blocks, every red block is a block. Kind of make sense what we're getting at here? Now, first things first. Most of us in here, I know some of you have had quite a bit of programming. Right off the bat, this is going to start becoming intimidating because we're creating so many separate classes, right? But what we're going to notice in the end is we're going to have all these little classes and they're not going to have much crap in them. Every one of them is going to be pretty simple. And when we bring it all together in the end, we're going to actually see how clean our code is as opposed to this scary main that almost isn't doable because we lack the tools to do it recursively. We basically had to just keep saying that, okay, well, we have our variable, what do we call it? Our JSON var. Well, JSON vars can be in 4 different flavors. Well, if it's this kind of flavor, now we kind of got to go deeper. Well, how deep does it go? You know, how many layers down does it go? JSON doesn't have a limit. You know, we could have a JSON object with JSON objects with JSON objects within JSON objects within JSON objects over and over and over and over again. You get to the point where you're thinking, okay, how complex is the data I'm representing? You know, is this really appropriate for JSON? But nothing prevents us from doing that. So really, we hit a wall with our previous implementation. Our previous implementation had a goal of textually capturing the pieces that we were interested in, right? And we did that. We met that goal. We got the simple values, we got the dumb values, we got the object values, and we got the array values. But now to pull meaning out of those would require us to go to a step further. Well, we're going to see that all of those have patterns associated with each other. And if we can build these individual objects, we can say, oh, I need to go ahead and parse a value. Parsing a value then determines what kind of value, and it parses the special kind of value, the specific kind of value. So to kind of finish this off for today, a JSimple value extends JVal. A JSimple value is going to have a private string, we'll call this guy the value. Write a constructor, take a string as a parameter, say this dot the value is equal to the value. And that's all it'll do for right now. So we have the ability to create JSimple vals by passing it a string value. So that's all a JSimple val is now. Now if we go back to a JSimple var, we no longer need this guy. So I'm going to delete him. Don't need jsimplevars. Why? Because now we can come into a jvar and say that every single jvar is a collection of a var name and a private jval varval. Because we created this abstract class. This is kind of like saying every block, well, every colored block we have here is a collection of its color and a block, the block that's under the hood. Okay, so a jval represents all four of our different kinds of values. We've only implemented one of them, that is the jsimplval, which is a jval. Okay, so in jvar, every single jvar we ever create will always have a string var name, and it will always have a var val of type jval. It's jvals that have some more complexity under the hood. So when we create our jvar, this guy will take in a jval as well, and we'll set this dot varval equal to varval. So that's going to be our current version of jval. We can't do anything with it, but we are storing the data. Okay? Now when we go back to jparser, what we can do here is once we parsed our simple variable value, we now have the ability to create a jvar. Why? Well, we have the var value, which is a string, and we've also parsed the var name. We have everything that we need to create a jvar, which has a string var value, and a jval, of which we want to create a jsimplval, which just takes in the string value. And then we can pass both of those values to jvar, building a jvar out of the variable name and the jval value. We have the two pieces we need. So the last step that we'll do on Monday is build our jval out of that simple value, or jsimplval. Build our jvar out of our variable name and the jval we just created. All right. Then we'll do the same thing for the other three, and at that point we'll have all the tools that we need to recursively make calls to do all this. All right. I will see everybody on Friday for the midterm.
Parse really quick.
Huh?